This video also continues dispersion for scale variables. Specifically, this video talks about dispersion around the mean, and you should focus on variance and standard deviation. I will go over other methods of finding dispersion around the mean, but you should focus on these two, and the one you should focus on the most is the standard deviation. So we need to get rid of the signs when we're adding up the deviations from the mean. We don't want them to add to 0. So there's two options. We can take the absolute values of the deviations, or we can square the deviations. Both of these ways will get rid of the negative signs. When we average the squares, it's called variance. Variance has what I call magical in math properties. And it's easier to do math with squares than it is to do with absolute values, and use those in algebra and also in calculus. And even though you don't need to know calculus for this class, it's kind of used behind the scenes in statistics, and then it's specifically used in statistical theory, which you don't need to know, but you just need to know it has these magical properties, I mean. So we will always use variance instead of the mean absolute deviation. So we're going to use the square version instead of the absolute value version. And the squared version is called variance. So variance wins. And you can see the footnote on standard deviation at mathisfun.com, and this will kind of explain a little bit more why we use variance over the absolute value version. So before we talked about how variance wasn't interpretable, and so we're going to take the square root of variance to make it more interpretable. But I'm going to talk a little bit further about how to interpret the standard deviation. Here's a definition of standard deviation. The standard deviation is the typical amount the scores vary or deviate from the mean. Technically, it is not the average deviation, because we are also scoring the n or the n minus 1, but it's close to it. So when we take the square root of variance, we're squaring the top of the formula to get rid of the squares, but in the process, we're also taking the square root of the n or the n minus 1. So technically, because we're squaring the bottom two, it's not the average deviation, but it's close to it. So you can kind of think of standard deviation to be almost the average amount of deviation from the mean. Close, but not all the way. Here's a rule of thumb that you can use. A typical person is between 1 standard deviation below the mean and 1 standard deviation above the mean. And here's another rule of thumb you can use. Almost all people will be between 3 standard deviations below the mean and 3 standard deviations above the mean. So here's an example of how to interpret the standard deviation. If you Google ACT scores, you'll find that the national average of ACT scores is 20.8. The standard deviation of those scores is 4.8. And the distribution is bell-shaped. Remember, bell-shaped means it's mountain-shaped, like this. So on here I have these lines, and the middle one represents the mean, because remember the mean for a bell-shaped histogram is in the middle. And then now we're going to go out 3 standard deviations above and below the mean. So let's go above first. We're going to go above one standard deviation above the mean. And so we're going to take 20.8 and add 4.8 to get 25.6. So 25.6 is 1 standard deviation above the mean. Now we're going to go below the mean 1 standard deviation. So 20.8 minus 4.8. So we're going to the left here, 1 standard deviation, and that equals 16. So we can say that a typical person scores between 16 and 25.6 on the ACT. So you're saying that a typical person scores between 1 standard deviation below the mean and 1 standard deviation above the mean. And to go above the mean, we add 1 standard deviation, and to go below the mean, we subtract 1 standard deviation. Now we're going to go out 2 standard deviations above and below the mean. So if we go another standard deviation, we add another 4.8, we get 30.4. If you go below, we're going to subtract off another 4.8, and we're going to get 11.2. And then we're going to go out 3 standard deviations. And if we go above, we're going to add another 4.8, and that's 35.2. And if we go below the mean, another standard deviation, that's going to be 6.4. So this 6.4 is 3 standard deviations below the mean, and 35.2 is 3 standard deviations above the mean. So we can say that almost everyone scores between 6.4 and 35.2 on the ACT. So everyone will score, or almost everyone will score between 3 standard deviations below the mean and 3 standard deviations above the mean. Now we're going to talk about what an outlier is. An outlier is an observation that is extremely small or extremely big. When discussing dispersion around the mean, we will define an outlier as being more than 3 standard deviations above or below the mean. So here's an example. So remember that in our ACT example, 3 standard deviations below the mean was 6.4, and 3 standard deviations above the mean was 35.2. Thus, scores of 5 and 36 would be considered outliers. So here we have our histogram again, and 3 standard deviations below the mean was 6.4, and 3 standard deviations above the mean was 35.2. So if we have a score of 5, that means there would be an outlier, and it would be an extremely small value. And then if you had a score 36, which is a perfect score, that would be an outlier, but on the higher end. So these two scores would be considered outliers because they're extremely small or extremely big.